number one, we are looking for a maximum. So how do we find the maximum of a function? We've got to take the derivative. So if f equals that, f prime equals what? Cosine of 1 over x squared times 1. Okay? So that's f prime. Now what do I do?
Graph it.
Yeah, this is a graph. This is a calculator problem, so you graph it, and you're looking for when what? When it changes from positive to negative. Now, we also do have a domain where it includes the endpoint. So we got 1/3 here, we got 1 there. We're going to set this equal to 0. What were the values when it equals 0, I guess? Why'd I what? I don't know, because I thought it said negative 1/3 there. Okay, what was it? Point what? 460?
Oh, wait, 1.
461?
Yeah.
Was there any other ones?
There was 2 others, but they didn't change from positive to negative. They went from negative to positive.
Oh, before this? There was one before it?
One before and one after.
Okay. Oh. Okay. So this was 0.461. So this was negative, positive, and then negative, positive, something like that?
Yeah.
So that means this is a relative max. But we can also say that this is a relative max, right? And that is a relative max. But those options aren't there, so we say D's the answer. Granted, it says 0.462, sorry, typo. All right, given the table that we have here, f is continuous and differentiable. The table above gives select values of f on the interval. Which of the following statements must be true? Does f, let's see, the minimum value of f is 2. Does that have to be true? Is 2 the lowest value there? Yes, it is, but because this is a table of values of a continuous function, this doesn't represent all values. So could it go below there? Yes. Is the maximum value 4? Not necessarily. It could be, but it doesn't have to be. Is f of x greater than 0 from 0 to 4? In that table it is, but does that mean it's positive in between those values? No. So that's not necessarily true. D, does f prime have to be negative from 2 to 4? Well, what's f prime mean? You're finding the slope, right? So, in fact, you could prove that one wrong just by the slope between 0 and 1. The slope would be 1 over 1 is positive. But even if that was the case, even if all those slopes were negative, does it imply that it would always be negative? No. E, there exists a C value for which f prime of C equals 0. How do you know that?
Because it changes from increasing to decreasing.
Fair enough, since it's differentiable. Yeah, because the function, you can observe the function increasing and then going to decreasing. You must have a 0 slope somewhere, right? Unless the slope does not exist, like you have a corner. But it says it's differentiable, right? But what other thing could I do to show this one? F of 4 minus f of 0 over 4 minus 0. So what is that? That's 2 minus 2 over 4 minus 0, which is 0. So what is this? What did we just find? Average slope, also the slope of the... If the average, it's the average slope. It's the slope of the secant line, right? And what can we say? Since the slope of the secant line is 0...
There's some point on that.
Just C where f.
So somewhere between 0 and 4, there's an x value, we call it C, where the slope will be 0. So